Arima, short for autoregressive integrated moving average, is actually a class of models that explains a given time series based on its past values, that is, its own lags and the lagged forecast errors, so that equation can be used to forecast future values. Any non-seasonal time series that exhibits patterns and is not a random white noise can be modeled with Arima models. An Arima model is characterized by three terms P, D, Q, where P is the order of the AR term, Q is the order of the MA term, D is the number of differencing required to make the time series stationary. If a time series has seasonal patterns, then you need to add seasonal terms and it becomes Sarima, short for seasonal Arima. More on that we will discuss once we finish Arima. See, what is the P, D, and Q in Arima model? The term autoregressive in Arima means it is a linear regression model that uses its own lags as predictors. Linear regression models, as you know, work best when the predictors are not correlated and are independent of each other. So, how to make a series stationary? The most common approach is to differentiate, that is, subtract the previous value from the current value. Sometimes, depending on the complexity of the series, more than one differencing may be needed. The value of D, therefore, is the minimum number of differencing needed to make the series stationary. And if the time series is already stationary, then D is equal to 0. Next, what are the P and Q terms? P is the order of the auto-regressive AR term. It refers to the number of lags of Y to be used as predictors. And Q is the order of the moving average MA term. It refers to the number of lagged forecast errors that should go into the Arima model. Now, what are AR and MA models? What is the actual mathematical formula for the AR and MA models? A pure autoregressive model is the one where yt depends only on its own lags. That is, yt is a function of the lags of uh, yt. That means it is given by the equation, it is given here, where yt minus 1 is the lag 1 of the series. Likewise, a pure moving average model is the um, one where yt depends only on the lagged forecast errors given by the equation given here, where the error terms are the errors of the auto-regressive models of the respective lags. The errors et and et minus 1 are the errors from the following equations. That was AR and MA models respectively. So what is the equation of an Arima model looks like? An Arima model is the one where the time series was differenced at least once it to make it stationary, and you combine the AR and the MA terms. So the equation is this. The summary of Arima model, that is the predicted yt is equal to constant plus linear combination of lags of y up to p lags plus linear combination of lagged forecast errors, that is up to q lags. The objective is therefore to identify the values of P, D, and Q. Now, how to find the differencing D in Arima model? The purpose of differencing it to make the time series stationary. So that part we will discuss in the next video. So this is an introduction to Arima model.